Okay, welcome to example 2 of pop intro to pops. In this one we're going to talk about groups and specifically pop groups. We have talked about point groups and grouping in sub context, but now we're going to talk about grouping particles. So this can be very useful for gaining more control over your simulations, grouping of parts, or even grouping things before your .NET. Anyway, we're going to talk about grouping things inside of .NET, so let's dive into it. I'm going to show you three different methods that I very regularly use when I work. We're going to group by bounding, we're going to group by expressions, and then we're going to group by expression and another random method. And I'm going to show you guys how to do it. So let's just watch the simulation to begin with. We have done, just put the velocity upwards. So the particles go upwards when we press play and simulate. So now we're going to take a look at the bounding. So I'm going to enable these two. And you can see there's a bounding here showing up. So basically a pop group is very similar to a group you can do in the sub context. It has a couple of similar things and a couple of things that are not so similar. The rule thing is actually grouping it by writing vex code. We're going to take a look at that later on in these two examples, but in this one we're going to group by binding. So by grouping by binding, it's basically like grouping by an incoming object. We can group by many different kind of like bounding types. Here we have a box that we can define the size and the position of. We can do a sphere. We can do an object where we have to either define the sub pattern or the sub path, or we can drop down a cube. We can drop down a box, pipe it into the second input. Just take a look where it is. Move it up a little bit like that, and go back in. And we can then define that it's the second context geometry, because the first one we have the points going in. We can decide the boxes here. This means you can actually replace this with any geometry and it will group it. So let's still do it with a bounding box. I've defined the size, I've defined the position, and I've called this group, the group name here you define by group 1. I've called it group 1. Anyway, that's all you need to do. Then I've done a color here, pop color, and I've set it to group 1. So all the points that are inside the group 1 will get colored red. Let's see if it works. Let's press play. And as you can see, it does work. So every point that ever comes inside of this box is going to be grouped. And we're going to put into the group called group 1. That's a very simple method of doing it and very similar to methods you can do up in the sub context. Now we're going to take a look at the expression one. So let's disable that. And as you can see, it's back to normal. Now we're gonna group here by the age of the particles. So remember how we talked about last example, that every particle has an age to it, defined by the life here. And these age, the age is basically like age equal to 1 is equal to 24 frames. Age equal to 2 is 48 frames. So that's basically how long the particles have lived for. So if it has lived for 24 frames, the age is equal to 1. What I'm going to do here, I'm going to enable these, and I want to group the points, every point that has lived for longer than, let's say, 2.5 seconds. So that would be 48, it would be like 60 frames, would it be? Yeah, 60 frames. So after 60 frames, I'm going to group every point that is still living, which is going to be most of them. So I'm going to do that. I'm going to do it in the rule tab here. And the way I write it is, so basically it's going to be like this to begin with, right? It's going to be like this. I enable it. I write at age, which is the attribute. If it's bigger than 2.5, then we group it. we have to do this thing afterwards, since it's vex, and that should be it. And then we call the group name group 2, and we're gonna do the same here. We're gonna color them, so we're gonna add group 2, and we're gonna do it color to yellow, and let's see what happens. As you can see, there is the color, and as you can see that well, the first couple of, they're roughly around 60, I guess, but yeah. But the age is now grouped. Every particle that has an age greater than 2.5 is being grouped. I put it to 2. Okay, well, that explains it. So after 48 they are grouped. Anyway, that doesn't matter. But all the particles that have a age greater than 2 is now in this group called group 2. And I mean, what can we do with groups? Why are they useful? Well, we can do things like this. Let's just do a simple thing here. Let's add a pop force. Let's actually set it to group, to only work on a certain group. And let's type group 2, because that's a group generated by this. Let's put the amplitude to 1. Let's put the swirl size to 2. Let's put the pulse length to 0.8, and let's put some force in a random direction like that. And now let's see, so it's going upwards, and boom. That's pretty cool, huh? Like, so we can actually control it like this. So once it enters a group, we can do random effects on it, or like modify it somehow, which gives us a lot of control over our things, and this is super useful. So I'm gonna delete this. And now we're gonna take a look at a third example here, and I don't want to use a lot to get some random things going on, because you always want to strive for randomness, because nature is always like really random. It's a random harmony, kind of. I don't know how to describe it, whatever. But so the first 2 steps of this is actually gonna be the exact same. We're gonna enable these, and we're gonna make a group called group 31, whatever. And we're gonna group every particle that has an age greater than 3.2. I'm gonna change it to 2 actually. So we're gonna group all the points that have an age greater than 2. They're gonna be put into the group 31. Simple as that. Then what we wanna do? We wanna do a second step to this. We're gonna add another group here. So we have group 31 here. Okay, remember that. We're gonna add another pop group. We're gonna check the source group and put group 31 here. So the source group going into this group is 31. So the only particles that is possibly can be grouped by this new group is all the particles that are in this original group here. It might get a little bit convoluted, but you will understand in a second, okay? So we have a second group here. We are only working on this group. We're gonna call this group group 3. Instead of rule or bounding, we're now going to go to random. We're going to enable it, and we're going to put a chance of 35. So 35% of all the particles will be put into this group. Okay? So basically what that means is, of group 31, 35% of that group is going to be put into this even newer group that is called group 3. And this group, group 3, we're going to color it by purple. Okay? Actually, yeah, let's color it by purple. And let's have a look what that looks like. So it goes, and boom. And you can see, only 35% of the particles are now grouped, which means that only 35 of the particles get colored. I'm going to demonstrate it even more clearly. And I'm going to add another pop force. And we're going to type check group, type group 3. I'm going to add some random things going on. Pulse length. We're going to add like that. Okay? Cool. So when we play this now, we're gonna see this. So only the particles that get grouped in this group 3 here are being affected. So that's like a 2-step grouping, which is kind of useful. There's other ways to get around this, but sometimes I'm lazy and do it with these 2 nodes of these, and it works quite well. Like I have a lot of good success with it, so it's a very useful thing, I think. But yeah, that's it for the grouping. This is 3 different methods that I use a lot. What else can you do? You can do combining and stuff, but that's a little bit of course. I'll go over that later on, but that's also kind of useful. Yeah, and basically you can group by any attribute. You can type here velocity. You can group particles that are fast. You can have, there's even different like things here. You can group every 5th. That's also like a random. Like you can group fast particles, no particles. You can group by any attribute here. We're just typing the vex code for it. It's quite simple, but very useful and very handy. So I hope you learned something in this tutorial. See you in the next example. Bye.